Hello, and welcome to today's on-demand demonstration of Quali's Torque platform. Today, I'm going to start with the view of an end user accessing the self-service catalog to get access to an environment that I need as a developer to validate my code. This is the catalog view, and it allows you to filter across different technologies, maybe, and different clouds. Today, I'm going to look for my VM on Azure. I can take note of the cost and have a description of what this environment provides. But as a developer, I know that this is the one that I use. I can see additional information about it, but I just want to get to work. So I'm going to hit launch. The first thing to notice is that as a developer, I don't need this to run forever. I can run this for up to 4 hours as specified by the administrators, but because I can access this on demand and spin up this environment in minutes, I only want to grab it for 2 hours. If I need to, I could add collaborators that could access the environment with me if I'm doing joint coding or troubleshooting. But right now, I'm just going to launch this environment for myself. There's some input parameters that if I wanted to change these, it gives me that capability. And for reporting purposes later on, one of the many tags that Torque applies against resources created is exposed to the end user, and I'm going to say that I'm doing development for this. The final thing to notice is that there is a workflow that applies to this environment, which will power off the VMs at the end of the day. In case I am working across that time, I'll want to keep note of that. All right, I've launched my environment and Torque has deployed it successfully. I know that it's active. I actually received an email notification from the system, so I didn't have to wait for it to finish deploying. It only took minutes, but I had time to go do something. And when I got that email, I logged in to see this. As a developer, I've got all of the resources I need at my fingertips, all of the information about this environment, as well as the ability through actions to perform actions against the infrastructure within this environment. If I change my mind, decide to add a collaborator, I can do that right now. I can choose from the users, and I'm going to add Chris because I need help with this particular thing that I'm working on. Now, if for some reason I wanted to understand how this was deployed, I could look back at the grains layout, which gives us the infrastructure as code view. And I see that it was deployed from a Helm module that deployed a Bastion host, as well as the virtual machine that came from a Terraform file. The quick links are provided here also, as well as in the resource view. And if I wanted to view the logs, I could see what happened during deployment. But everything's green, so I know this environment is good. So we demonstrated from the perspective of an end user, a developer, a QA engineer, maybe even a sales demo engineer, how to access environments through our self-service catalog. But at Quali, we know that the bottleneck in the organization is often for every 100 or 1,000 developers, you've got maybe 10 DevOps or IT practitioners that are trying to provide them service. How did we create this catalog? Did we make their lives easier? And the answer is yes. So many companies are moving towards automation based on infrastructure as code. We allow you to quickly discover pre-existing assets that you have stored in your Git repositories. We've added these repositories, and now we can select from any of the Terraform modules, Helm modules, Kubernetes, or even CloudFormation modules that you have available. Today, I'm going to grab my robot shop. This is a e-commerce site for buying and selling robots, but I also need an RDS and a infrastructure. So I'm going to automatically generate a blueprint with these, and we'll move to the next screen. You can see that it provides inputs and outputs after it's scanned your modules, and then it creates a building block that we refer to as a grain that allows you to combine these in interesting ways. So I launched a blueprint that was based upon the auto-discovered assets, the RDS, the robot shop. And I'd like to go from here, which is a live environment, to what we call a blueprint view. The blueprint view shows you what our blueprints are comprised of and how a blueprint can be used to orchestrate across multiple technologies. So here we have 2 Terraform modules that are combined with a Helm-based Kubernetes module. And this took minutes to put together versus the complex scripting and testing and validation that would be required to do this manually. Now that we have this blueprint in our standard list of blueprints, we have the ability to do actions on them, such as manage the policies, to set duration limits. You can have this one for 3 days. To launch it from here, I can publish the blueprint, and I can also require approval. So now that we've created our blueprints, one of the next steps to take is to create policies that allow guardrails to be put in place for safe usage of those blueprints. A common way to do this is built-in policies that we have out of the box to allow only private storage or prohibited instance types. In this instance, we want to ensure that only certain regions are allowed for deployment. And here you can see that US West is the only one that will be allowed. If a user attempts to deploy in a region outside the ones listed, before the environment is launched, the policy will stop the launch and it will notify the administrators and the user that only US West 1 is allowed. Policies can be set on things such as cost or duration, and this all helps the end user to be secure in launching his environments, as well as for the DevOps, the DevSecOps people, the security people, to know that environments will always be launched per the allowed policies of a company. If we wanted to add a policy that you had, you could connect one from your repository, and we could use any GitHub type repository, just like we do for blueprints and assets. So now policies as code is available as well. So another powerful capability within Torque is to build on actions on individual resources and create workflows out of those. So here we're creating a complementary workflow to the power off Windows VMs workflow. We want to power on those VMs, and this will power on all the Windows VMs in an environment that is created by the end user. This workflow is built on the power on action, but you can see that I can select any of the available actions. I want this not to apply to all spaces, so I'll select a space to scope it to that space. And then I can also select this for Monday through Friday, and let's say that's going to happen at 9 a.m. And this will respect time zones for the user that launched the environment. As we saw, workflows can be set up by the Torque administrator and are managed in one location. But in the theme of self-service, we want to continue to enable an end user to manage his environment. We do have power off Azure Windows VM for this simple environment. There's only one VM, but if this were more complex, maybe that end user wants to use a workflow that was enabled by the administrators. Within this one, if there were, say, tens or hundreds of VMs within my environment, I could run this workflow to power them all off automatically. I could also, looking at the workflow and to see when it's going to run, decide that I need to delay this for a certain amount of time. Workflows and actions are also governed by policies. So when I ask to extend or to delay the workflow, that will be checked by our custom policies as well. While Torque allows the end user and the DevOps teams to quickly create environments that can be spun up or spun down. Some environments are meant to be longer running. For those, you want to keep an eye on the environment to see if there's any change in the production resources that are different from the way that you decided to launch it as per the specification or design in the blueprint. When I look at my environment, I've got the overview of the environments, and I can see that I've been notified by Torque that there's been changes to the resources on the cloud account. So to investigate, I'm going to click into the blueprint, and I see that this Terraform module that launched the S3 app, something on the cloud side of the running resource itself has changed. To look at that change, I would review it here, and I look to see somebody changed the Torque owner email from my email address to drift detection. That's not a change that we want, so I would decide to reconcile this drift, and that would reset this cloud resource back to its original design intention. A lot of our customers and end users find this very useful for managing environments long-term. So because of the auto tagging that we demonstrated earlier, and because of the consistency in the way that we launch cloud environments, Torque has the capability to report on cost at a much finer level of detail than many platforms. We can start by reviewing the monthly cost associated with individual cloud accounts and across cloud accounts. Because of the historical data that we collect on the expected cost of a blueprint, we can also forecast what the spend for this account would be based on what's been there in the past. Another interesting view is to look at the cost per blueprint. For Quali, we look at the blueprint, which translates to a specific type of environment, as the business context that brings together users, cloud resources, cloud accounts for a specific purpose. Now, at a higher level, if you want to look at it at the space, a space could be a production environment, it could be an application-based or a team-based space, and then you can see the cost at that level. Finally, if you'd like to see individual cost elements, all of these aggregate from live environments or from environments that were launched from Torque. And this is where you would see the environment that was launched, how much each environment cost, how long it ran, and who the owner was, as well as connected back to the blueprint that launched it. This gives teams a much finer grain level of detail to help their the FinOps team and the people concerned about cloud costs to manage those costs and to make decisions based on real business context data.